Have you ever stood on a massive bridge, feeling the vibrations beneath your feet as cars zoom by, or stared up at its towering cables stretching into the sky? Giant bridges don't just connect 2 points. They connect people, cultures, and even eras of history. They are marvels of human ambition, engineering, and determination. But have you ever wondered why they were built, how they're made, and what makes them so important to us? To understand bridges, we need to go back to their simplest purpose: solving problems. Nature often separates us with rivers, valleys, or seas. Bridges are humanity's answer to the question, how do we get to the other side? Early civilizations built rudimentary bridges using logs or stones. These early structures may have been simple, but they were transformative. They made trade possible, connected settlements, and allowed cultures to thrive. As societies grew, so did the need for better, longer, and stronger bridges. But giant bridges, those spanning vast distances or soaring high above the ground, are more than functional. They represent a leap of faith. Building a massive bridge often requires a tremendous investment of time, resources, and ingenuity. So why go to such lengths? Because bridges are also statements of power, progress, and unity. They demonstrate what humanity can achieve when we dream big. Building a giant bridge is one of the greatest challenges in engineering. It's not just about connecting 2 points. It's about battling gravity, weather, and the unpredictable forces of nature. Imagine constructing a bridge across a massive canyon or over a turbulent sea. Engineers must account for wind, tides, earthquakes, and even the weight of the bridge itself. And the bigger the bridge, the bigger these challenges become. For instance, wind is a constant threat. If a bridge is too rigid, it might snap under stress. But if it's too flexible, it can sway dangerously, even collapse. Engineers have to find the perfect balance between strength and flexibility. A balance that takes years of research and planning. Then there's the weight. Some giant bridges stretch for miles and support thousands of tons of vehicles daily. The materials used need to be strong enough to handle this immense load without wearing down. This is where innovations in steel and reinforced concrete come into play. And we can't forget the environment. Building in remote or extreme locations means transporting materials, workers, and equipment to places that are sometimes nearly inaccessible. Every bridge is a puzzle, and solving it requires ingenuity, teamwork, and a little bit of luck. Not all giant bridges are created equal. There are several types, each designed for specific challenges. Suspension bridges are probably the most iconic. Picture a bridge with massive cables draped like a necklace between 2 towers. These cables distribute the bridge's weight, making it possible to span vast distances. Suspension bridges are perfect for crossing wide rivers or bays, and their elegant designs make them architectural landmarks. Arch bridges, on the other hand, rely on the natural strength of an arch to carry the load. These are some of the oldest bridge designs, but modern materials have allowed them to reach unprecedented sizes. Their solid and sturdy appearance often fits beautifully into natural landscapes. Cable-stayed bridges are similar to suspension bridges, but rely on cables directly connected to the bridge towers. This design is efficient and visually striking, with its geometric patterns of cables fanning out like the strings of a harp. And then there are beam bridges, the simplest and most practical. These rely on horizontal beams supported by piers. While they might not have the elegance of suspension or cable-stayed bridges, beam bridges are often used for long, flat spans where efficiency is key. The materials used to build giant bridges are a testament to human ingenuity. Early bridges were made of stone, wood, or iron, but today's giants are built with steel and reinforced concrete. Steel is a game changer. It's incredibly strong and flexible, which makes it ideal for handling the stresses of long spans and heavy loads. Reinforced concrete combines the strength of concrete with the flexibility of steel, creating a material that can withstand both compression and tension. But modern bridges go beyond materials. Advances in technology, like 3D modeling and wind tunnel testing, allow engineers to predict and solve problems before construction even begins. Drones and AI are also used to monitor the condition of bridges, ensuring they remain safe for decades to come. Giant bridges are more than feats of engineering. They're symbols of connection. They bring people and places together, turning obstacles into opportunities. Think about how a bridge transforms a region. A once isolated community becomes a hub for trade and tourism. A city divided by a river becomes unified. Giant bridges shrink the world, making it easier to travel, trade, and share ideas. But bridges also symbolize resilience. They are built to withstand hurricanes, earthquakes, and the test of time. In moments of crisis, they often become lifelines, ensuring that people and supplies can reach those in need. Why do bridges fascinate us? Perhaps it's their scale. Standing on a giant bridge with the ground far below and the horizon stretching endlessly ahead is a humbling experience. Bridges remind us of the vastness of the world and our ability to conquer it. Bridges are also deeply symbolic. They represent hope, progress, and unity. They're a promise that no matter how divided we may seem, we can always find a way to connect. It's no wonder that so many artists, poets, and filmmakers have been inspired by these structures. They speak to something universal in all of us. So, what's next for giant bridges? As cities grow and transportation needs increase, the demand for bigger, smarter, and more sustainable bridges is rising. Future bridges may incorporate renewable energy, like solar panels or wind turbines, making them not just pathways but power sources. Advances in materials such as carbon fiber and self-healing concrete promise to make bridges stronger, lighter, and longer lasting. We might even see underwater or floating bridges, pushing the boundaries of what's possible. The bridges of tomorrow won't just connect places, they'll connect ideas, industries, and possibilities we haven't even imagined yet. So the next time you cross a bridge, whether it's a simple one in your hometown or a giant that stretches across the ocean, take a moment to appreciate its story. It's not just a structure, it's a triumph of human imagination and determination. Bridges are a testament to our ability to overcome obstacles, to unite what was once divided, and to dream beyond the horizon. And that is why giant bridges will always be more than just pathways. They are pathways to progress, connection, and a brighter future.